Welcome to the Copper Spice YouTube channel, and thanks for joining us. In this video, we are going to talk about special member functions and some of the issues and considerations surrounding them. Special member functions. We are going to start with some definitions to explain what special member functions are and why they're called special. Then we're going to talk about which functions are considered to be the special member functions, like some of the constructors and assignment operators. The other item we would like to mention is the spaceship operator, which is expected to be included in the C++ 20 release.
Special member function is a defined term in the C++ standard. To understand what a special member function is, we have to first define a member function. A lot of programmers, including us on the Copper Spice team, use the term method when talking about functions in a class. The C++ standard never uses the term method. Instead, it refers to these as member functions. So a special member function is nothing more than a normal class method or function which the compiler can generate for your class. The C++ 98 standard defines 4 special member functions, and then 2 more were added in C++ 11. When the compiler generates an implementation for a special member function, there are certain rules it will follow. The generated function is always public and inline. They are also non-virtual unless they end up overriding an existing virtual method in a parent class. If the function the compiler is generating is a copy operation, it will only do a shallow copy. This means the data members in your class will be copied, but not the things they point to. If your class has data members which are pointers or complex data types, then a shallow copy may not work or may not do what you need. If this is the case, it will be important to set up your class so the compiler does not generate a special member function for copy operations. The basic idea is that special member functions are generated for you automatically, and yet the code added by the compiler will not be visible in your class. So in some cases, it may simply look like a call to a constructor is working, when in fact you never wrote the code. There are declarations you can add to your class which will have the effect of suppressing the generation of some or all of the special member functions.
A default constructor is one which is called when an object is initialized with no arguments. It must be able to receive an empty argument list, either because its parameter list is empty or every parameter has a default argument. The default constructor is a special member function, since one will be provided by the compiler if you do not declare any constructors in your class. As soon as you declare any other constructor, regardless of its parameter list, the default constructor will not be generated by the compiler. If you still want the compiler to generate the default constructor, there is a way to force the compiler to generate it. You simply add =default after the declaration and leave off the curly braces.
The compiler will also generate a destructor function for you. A destructor has the same name as the class, with a tilde prepended. A destructor cleans up after the object when it is going out of scope. Since this process is rather routine, it really usually makes sense for the compiler to generate the destructor for you, and usually it will be more efficient. The only way to prevent your class from having a destructor is to declare the destructor as deleted. A class without a destructor is not very common, since an instance of this class could never be destroyed. If you have a class with a deleted destructor, you can never declare an object of this type as a local variable. The only way to instantiate an object of this class would be to allocate it on the heap using new, and of course it can never be deleted.
Programmers often debate whether special member functions, which are intended to be generated by the compiler, should appear in the class and be marked as default, or simply not appear in the class declaration. Adding these methods and marking them as default will improve readability, especially for a user of the class. Now the user, or the next maintainer of the class, knows exactly which special member functions the compiler will generate. The constructor in this example is the default constructor because it can be called with 0 arguments. The constructor is declared as defaulted. The correct way to refer to this method is to call it a defaulted default constructor. The first word, defaulted, reflects the part of the declaration which says equals default. It does not refer to the fact that this is the default constructor. This is an example involving the default constructor. In my class A, the default constructor is again marked as equals default. This function will have a compiler-generated implementation and is not user-defined. However, by moving the equals default outside of the class, as shown in my class B, the constructor is considered to be user-defined. This is a bit odd, since even in my class B, the implementation is generated by the compiler. Usually this distinction is unimportant. However, there is a rule in the C++ standard which states only user-defined constructors can be called to initialize a const object. We tested various versions of Clang, GCC, and MSVC, trying to construct a const object of my class A. Versions of Clang between 3.2 and 3.8 report this as a compiler error. The error message says, default initialization of an object of const type const my class A without a user-provided default constructor. Later versions of Clang and all other compilers allow this code with no reported issue. We talked with someone on the Clang team, and they confirmed that when the compiler was changed in 3.2 to enforce this rule, programmers complained, and the restriction was eventually relaxed to conform to the way other compilers behave, rather than enforce the standard. If you are uneasy with the equal default outside the class, you can remove the equals default in my class A, and then just add curly braces. This would implement the constructor and makes it user-defined. Now you can initialize a const object of this class and be standards compliant.
The copy constructor is also a special member function. A copy constructor is one which can take an L-value reference to an instance of your class. This reference can be CV qualified, which means const or volatile can precede the data type. In almost every case, the correct parameter type for the copy constructor is the first one shown, which is const t reference data. A copy constructor can have multiple parameters as long as every one but the first has a default argument. If you do not declare a copy constructor, one will typically be generated by the compiler. If you wish to suppress the copy constructor, you may want to explicitly specify equals delete so that the intent is clear both to the compiler and to other programmers reading your code. If the compiler generates a copy constructor for your class, it's valuable to know what the implementation will actually do. The compiler will generate a copy constructor, which simply calls the copy constructors of all base classes and all data members. This is a shallow copy. If your class contains pointers, smart pointers, or other complex data types, this might be a problem. Both the old and the new object may be pointing to the same underlying data for some members, which may not be what you want. With a shallow copy, you will have two unique pointers, one in the original object and the other in the copy. However, if they are smart pointers, they will both point to the exact same data. If this is the desired behavior, then you're set. But often when making a copy of an object, you want completely separate data. In this case, you will need to provide your own declaration and implementation of the copy constructor. The typical way to look at this issue is that if you have a reason to declare a destructor in your class to clean up some memory allocation, you should most likely also implement the copy constructor. What is interesting is that when you declare a destructor in your class, the compiler will mark a compiler-generated copy constructor as deprecated. If anyone tries to call this compiler-deprecated copy constructor, They will get a warning, but the special function is still callable. The move constructor is similar to a copy constructor, but the parameter type is an R-value reference instead of an L-value reference. This R-value reference can be CV qualified, but in practice this is rarely, if ever, used. The normal signature is the first one listed, T && data. The purpose of a move constructor is to move data from an old object to a new object, potentially leaving the old object in some invalid state. The only thing you can or should do with the old move-from object is destroy it or assign a new value to it. Certain classes may make stronger guarantees about the state of a moved-from object. For example, stdUniquePointer guarantees that the moved-from pointer is set to null. In general, it's a good idea to assume a moved-from object is simply unusable, and that accessing it in any way may be undefined behavior. Don't count on any access to a moved-from object to be valid, and if it appears to work the way you expect, assume it is working by accident.
There are several different rules which govern when a particular special member function will be implicitly generated by the compiler. These rules are not based on what functions are being called, but rather on what other member functions are declared in your class. It is important to know when a move constructor will be generated by the compiler. If a copy constructor, copy assignment, move assignment, or destructor are explicitly declared, then the move constructor will not be generated for this class. Here is a simple example. By deleting the copy constructor, the compiler does not generate the move constructor. This class is not copy constructible, nor is it move constructible. If some code tries to call either the deleted copy constructor or the implicitly deleted move constructor, they will get a compiler error.
The copy assignment operator is another special member function and very similar to the copy constructor. The main difference is that the copy assignment operator is used to copy the value from an existing object to another existing object, whereas the copy constructor is used to make a new object and then copy values into it from some existing object. The behavior of the compiler-generated copy assignment is similar to the copy constructor we discussed previously. It simply calls the copy assignment operator for all the base classes and all the data members. One other minor difference is that the copy assignment operator can receive its parameter by value. If you write a user-defined copy assignment function which takes its parameter by value, then before this function is called, the copy constructor will be called implicitly. In other words, your copy constructor will be called first, and then this copied value will be passed to your copy assignment operator function. This is not usually what you want, and it's not usually what you've expected. It is also worth noting that the copy assignment operator must have exactly one parameter, in contrast to the copy constructor, which can have extra parameters as long as they are defaulted.
The move assignment operator is very similar to the copy assignment operator. The parameter must be an R-value reference, just like the move constructor. The compiler-generated implementation operates as you would expect by calling the move assignment operators for all the base classes and data members. Like the move constructor, after doing a move assignment, you should not access the moved from object in any way, as this might be undefined behavior. There is another operator function which has some unusual properties, and some wonder why this is not a special member function. To be clear, it is not a special member function. We have talked about special member functions and how they are generated for you, including assignment operators. The other operators, which can be overloaded, are not special member functions, so they cannot be used with your class unless you declare and implement them. The exception to this rule is the address of operator, which can be applied to any object even if you did not declare an address of operator overload. According to the C++ standard, the address of function is not a special member function, since the compiler is not actually generating anything for your class. It is simply applying the built-in definition of the address of operator. If you were to implement this function in your class, it would fall under the jurisdiction of overload resolution.
There is a new operator being added to the language in C++20. While many of the details are still being worked out, it looks like, as of C++20, there will be a new special member function called the spaceship operator. The 6 existing relational comparison operators will all become special member functions that the compiler can generate for you, given that you have added an implementation of the spaceship operator in your class. The spaceship operator itself can be generated by the compiler if all data members in your class provide an implementation. The compiler-generated implementations will be designed to be more efficient and reduce a great deal of duplicated code. As we get closer to the ratification of C++20, more information about this new operator will be available, and we expect the topic of special member functions to be quite vibrant. For more information about the CopperSpice team and our projects, please visit our website at www.copperspice.com.
Thanks for watching. We hope you found the content of value. If you have any questions or feedback, feel free to leave a comment on this video or send us email.
Please make sure you subscribe to our YouTube channel and come back in 2 weeks for our next video.